All right, guys. So today we're going to be talking about the third type of distribution, the Poisson distribution. Um, the previous days we talked about the binomial distribution and the geometric distribution. So the binomial distribution counts the number of successes. The geometric distribution counts when the first success happens. The Poisson distribution is similar to the binomial distribution in that the random variable x will count the number of times an event occurs in a given intervals. So x is also counting the number of successes, but this time it is doing so in a given interval, which in this case, for this course, is going to be usually time. So this might be how many times something happens in a day, or how many times something happens in a week. So there's not a set number of trials or a set number of trials like a binomial distribution. Instead, we are doing things in a given time frame. The second condition as written is that the probability of success in each interval is the same. And the third one is that the probability of an event happening during one interval is independent of the probability of something happening in another interval. So for example, if the probability of selling a car for day one might be 60%, and the probability for selling a car on day two might be 30%. This still fits within Poisson distribution because those are two different days, and so they can have different probabilities. However, based on condition number 2, on day 1, throughout the whole day, the probability of success must be the same. So that is the main difference between these two conditions. The third formula for the formula for Poisson distribution is the probability of x amount of times of successes is equal to mu to the power of x times e to the power of negative mu all over the factorial of x. In this case, e is a constant. Most of you are probably familiar with pi, where pi is 3.1415 and so on. E can be approximately represented as 2.71. If you have a scientific calculator, you can also find E on your calculator. Usually it's on the bottom right or on the top right near the logarithms. If you see something with log or ln, usually you will see E near it. You might have to shift to get it. Otherwise, you can just use the approximate numerical value, which is about 2.71. So in this formula, aside from the constant, we only have two letters, which is mu and x. So mu is usually given, as we have studied before, mu represents the mean of something. So in this case, mu is the mean number of successes during a given interval. For example, we might say that the average number of cars that we sell in a day is 6, or the average amount of drinks that we sell at the snack shop each day is 20. We sell 20 drinks a day on average. And x is the random variable that we are trying to find. So we're trying to find what is the probability of x amount of things in one day or 1 month or 1 year, depending on the question. So with that being said, with this formula, we will do a few example problems with one scenario. In this case, the average number of cars sold at a store per day is 6. So here we know that mu is equal to 6. That is what is given. That is the average number of cars. So that means that the probability that a store sells 10 cars in one day becomes, instead of mu, we can write 6. X here is 10, right? That is the amount of cars that we are trying to find, multiplied by e to the power of negative 6. 6 is our average, all over the factorial of 10. So I will do this on a calculator. Even on your standard Windows calculator, if you're in scientific mode, usually there will be e. So I will start with 6 to the power of 10 times parentheses e to the power of negative 6. So negative, so e, oh, something went wrong there. Let me clear that. E to the power of negative 6. Negative, okay. Closing parentheses. So that's the multiplication. Yep. And then all divided by 10 factorial. So 10 factorial. So this gives me about 0.04, which you can leave that as the answer, 0.04, or you can also answer as 4%. So if the average number of cars sold is 6, then the probability of selling 10 cars in a single day is about 4%. So it's not likely, but out of 100 days, it should happen 4 days, right? That's basically what the percent means. So next up, the probability that the store sells less than 4 cars in a day. So the numbers that are less than 4 cars are 1, 2, and 3, right? Those are the numbers less than 4. In this case, is it possible that we sell 0 cars? And the answer is yes, right? We could sell 0 cars. So in this case, X does need to start at 0. 1, 2, 3, 4, 5. So that means that we will need to figure out these 4 values and then add them all up, right? So the first one, when X is 0, 6 to the power of 0, which is just 1, times e to the power of negative 6 over 0 factorial. 0 factorial ends up being 1. So in this case, our formula ends up just being e to the power of negative 6. So e to the power of negative 6. Which gives us 0.0025. So I'm going to leave that as a decimal, 0.0025. All right. Next up is X is equal to 1. So 6 to the power of 1 times, we already know that e to the power of negative 6 is this. So I'm just going to do 6 to the power of 1 is 6 times 0.0025 divided by 1 factorial, which is just 1, 0.015. Next up is 2. So 6 to the power of 2, which is 36, times 0.0025 divided by 2 factorial, which is 2, gives me 0.045. 0.045. And last one is 3. So 6 to the power of 3 times 0.0025. And then divide by 3 factorial, which is 6. Right? Divide by 3 factorial gives me 0.09. So the probability that the store sells less than 4 cars becomes 0.0025 plus 0.015 plus 0.045 plus 0.09. 0025 plus 0.015 plus 0.045 plus 0.09 gives me about 0.1525 or about 15%, right? I'm just going to round to the nearest percent in this case. So about 15%. The next question asks, what is the probability that the store sells at least 6 cars a day? So at least 6 cars means 6 and above, right? So in this case, instead of calculating everything above 6, as usual, if we add up all of our probabilities, it would equal 1, right? So we can also do 1 minus everything less than 6. Again, we already have the everything from 0 to 3, so we just need to do 2 more calculations for 4 and 5. So 0.0025 times, well, actually, let me clear that. It would be 6 to the power of 4, 6 to the power of 4 times 0.0025 divided by 4 factorial. Gives me about 13.5, 0.135. Next up is 5, 6 to the power of 5 times 0.0025 divided by 5 factorial. Give me 0.162. As usual, we'll add these all up. So we already know the first 3 adds up to be 0.1525. So I'm just going to add up the 4th and the 5th values. 0.135 plus 0.162 plus 0.135 plus 0.1525 gives me about 0.446. I'm just going to round it to 0.45, which means that if I do 1 minus 0.45, that gives me 0.55 or about 55%. So in this way, we found the probability that a store sells less than 6 cars. And then if we want at least 6 cars, it would be 1 minus that value, right? So that is pretty much everything you need to know about Poisson distribution. There are less variables. There's actually only one variable that you need to keep track of, and that's the mean. So as long as you can identify what the mean is and what x should be, or like what are the x values that you need to calculate and what you need to add, the rest of the process is relatively straightforward. As usual, if you have any questions, you can email me or talk to me during class. And I will see you guys tomorrow.